All right, guys. Hello, everyone. Okay, let's continue with integration. Last lecture, we look at the example where we're applying we only focus on the first standard integral. Number one, if I understand the standard integral number one, you can still go back to the last lecture. The following standard integral that we're going to look is this one. Number two, when you're integrating anything that is in this form, when you're integrating f prime over f of x dx, the integral of this form will be ln of f of x plus c. So if you integrate a derivative of the function over a function, the integral should be in this form. Okay, we're going to look at the example where we apply this standard integral. We call this standard integral a log form. A log form. We call this standard integral a basic log form. So let me rewrite this. If you integrate f prime over f prime over f of x dx, the integral or if we like, we can write this integral like this. We can say 1 over f of x times f prime of f of x dx. You see, you can write this f prime over f of x as 1 over f of x times f prime. Okay. Okay. I was still writing this basic log form. If you're integrating f prime over f of x dx, the integral is going to be, okay, first we can write the standard integral as 1 over f of x times f prime. Sometimes you find some standard in this form instead of this form. So sometimes it's f prime over f of x. Sometimes you can write as 1 over f of x actually multiplied by f prime dx. This means the same thing, So we say the integral of this form is ln of f of x, and then you say plus c as a formula change. As we see this second standard integral, the integral of this form is ln of f of x plus c. Okay. Let's look at the examples. Apply this standard integral. Examples. Evaluate the following integral. Number one, let's say we want to integrate cos of x over sine of x dx. Okay, let's go back to the standard integral formula. You see, it's the only standard integral that have a fraction, out of all these standard integrals. Number 2 is the only standard integral, which is a fraction. So what I mean, you can always start by looking for this form when you're integrating a fraction. Okay. This is the only standard integral. That is a fraction, integral of a fraction. But you can only apply this standard integral if you have this form, f prime over f of x, or this form, which is 1 over f of x times f prime. What you need to do is to let your denominator to be f of x, and check if the denominator itself a derivative in the numerator. You'll see that you have this form. And then the other thing, you see f of x here is to the power of 1. It's to the power of 1. If it's to the power of any other number except 1, you're going to use the first standard integral. This is form again. I'll show you like example. Okay, let's look at the first example. We want to integrate cos of x over sine of x with respect to x. So here, according to the standard integral, you let your f of x to be a denominator and check if you have a derivative in the numerator. Yeah. And then it means you have this standard form, so the integral of this form will be ln of f of x. Let's look here. If we always check, let your f of x to be a denominator, which is sine of x. You see sine of x is to the power of 1, which is fine. So if you check the derivative of this denominator function, we see it's cos of x. Cos of x, you go back to your function. Oh, you see I have the derivative of f of x, which is cos of x here. So now we have the form which is f prime over f of x, which is this form. Okay, we want to integrate something in this form f prime over f of x. So the integral of this form is ln of f of x. You see the integral doesn't have f prime, so it's ln, right, f of x plus c. So f of x in this case is sine of x. So what would be the integral for this one? If you use this formula, this will be given to you during the test. So the integral of this, because it's f prime over f of x, so it's going to be ln of f of x. My f of x is sine x. You can take a denominator. Ln of sine x plus c. Okay. This is the first method. Let's say this is the first method. Some student may write this cos of x over sine of x as cot, which is cot x dx. And you want to integrate cot x. We're still coming to this. We call it the trig form, the integral of trig form. It's given here. So you want to integrate in cot. You see the integral of cot. The integral of cot, your f of x here. You see you treat f of x as x. So if you have x, the derivative of x is 1. So your f prime is 1. So here, so f of x is x and f prime is 1. So you have this standard form, which is this one. So the integral of this will be ln of sine of f of x. You remember you said the f of x is x, so it's ln of sine of x. So which is this one. Same and, even if you use the trig form and. So also this, when we're using now the formula for cot. When we use the formula for cot, when you treat f of x as x, so the f prime will be 1. So it's just integral of cot x. The integral of cot x, f of x is x, is going to be ln sine of x plus c. You see this formula gives us the same answer. So according to this formula, the answer is also ln sine of f of x, which is x, plus c. We're getting the same answer. It's up to you. You can check if you have a fraction, which is a standard integral number 2, then use it. Or some students, they prefer to simplify everything. So if you simplify this, it's going to be cot x. You also have the trig form, standard of trig form. We're still going to do them. So you have the standard integral for cot. The integral of cot x is ln of sine x according to this formula. All right. Oh, okay. This was the first example. Let's look at the second example. Always when you have a fraction, think of the first standard integral first before simplification. So let's look at the number 2. Let's say now we want to integrate 1 over x plus 1 dx. So we have a fraction. You must have this standard form, which is standard integral number 2. Ilese sibhale phezulu but ngizibhala kabusha la ngoba okay, ibhodi alikho likhulu. So the integral of this form is ln of f of x plus c. As long you have this form, you always check the denominator if it's have a derivative in the numerator. So which means, and then your denominator is always to the power of 1. So you can check, you have a function which is x plus 1 is always to the power of 1 here. So you can let your f of x equal to x plus 1. And then your f prime is going to put the derivative of this is 1. You see you have a derivative of the denominator here. It's 1. So you have the form of f prime over f of x. F prime over f of x, the integral will be ln of f of x plus c. So the integral of this form is going to be ln of x plus 1, and then we'll say plus c. You're done. That's it. Now, just to check the understanding before I continue with this standard form. Now, let's say you want to integrate this. I want to include this example here. Rabbi Bohm wants to integrate x plus 1 squared dx. Let's say you want to integrate this 1 over x plus 1 squared. Remember, the only standard integral, which is a fraction integral of f prime over f of x dx, it's ln of f of x plus c. Okay? I'll keep writing this because it put the here. So you can apply this standard integral if you have f prime over f of x, and then your f of x is to the power of 1. Now your f of x, let's say you let f of x to be x plus 1, but now it's to the power of 2. I said if f of x is to the power of any other number, use the first standard integral. The first standard integral, this is from your last lecture, integral of f prime integral of f prime f of x to the power of n dx is going to be f of x to the power of n plus 1 over n plus 1 plus 2. This standard integral just say if you want to integrate a function that is to the power of n and there's a derivative of the inner function outside, you can just drop f prime and say f of x to the power of n plus 1 over n plus 1 plus c. So in the standard integral of this form, you drop f prime and integrating the box which contains f of x there. So n plus 1 over n plus 1 plus c. So in this case, I see I have a fraction, but my function in my denominator is to the power of 2, is not to the power of 1. Eh? So I'll take this to my numerator and just apply the first standard integral, because I can only able to use the standard integral if I have f prime over f of x, and then f of x is to the power of 1 here. Yeah? There's 1 if ngapha. So since it's to the power of 2, we're going to take it to the numerator and apply the first standard integral. Plus 1 to the power of minus 2 dx. All right. So we want to integrate this. We want to integrate this. So this might be this form. Eh? We have some function which is to the power of n. Eh? I'm sorry about this network local. So you must have this standard integral. This one, you have some function which is to the power of n. You must have a derivative, even if it is a constant. There might be a derivative. You always need to check if the f of x have its derivative outside there. So I will treat my f of x as x plus 1, and then check if I have derivative outside. The derivative of this is 1. Eh? There's 1 here. It's just that we not always write a constant number 1. Yeah? 1 here. So you have this form, which is f prime, f of x to the power of n, which is this form. So the integral of this form will be f of x. My f of x is x plus 1. So it's going to be f of x, which is x plus 1, to the power of n plus 1. N plus 1. Minus 2 plus 1 is minus 1, divided by n plus 1, which is minus 1. Your network goes. Your network. So this is the answer, or if you like, we can write this as, because this is to the power of negative 1, you can write as 1 over minus x plus 1 to the power of 1 plus c. Okay. So this is the integral of 1 over x plus 1 to the power of 2. Eh? Okay. So, okay, let's go and do another example, which is this one. Let's say now, this is example 4. We want to integrate e to the 4x over 1 plus 3e to the 4x dx. This is my number 3. I want to integrate this function. I want to find the integral of e to the 4x over 1 plus 3e to the 4x. So standard integral is f prime over f of x dx. The integral of this form is ln of f of x plus c. Okay. So you always check the denominator if it have a derivative in the numerator. So you have the function In the denominator, it's to the power of 1. You want to check if it's a derivative in the numerator. So I want to check my denominator function. I let it be equal to f of x, 1 plus 3e to the 4x. And check if I have f prime in my numerator here. So the derivative of this, derivative of constant is 0, and derivative of e to the function is going to be e to the function 4x multiplied by the derivative of the inner function, which is 4. So this 4 will multiply with 3 and make it 12 then. So this is the derivative of the f of x. This is the derivative of the denominator. This is the derivative of the denominator function. If I check here, I don't have the derivative of this denominator because the derivative of this denominator is 12e to the 4x. Remember what I said about the constant. Is in order to have a derivative of the denominator, you short with a constant 12 here. You see, you short with this constant 12 here. You short with the constant 12. So if you short with a constant, you can always introduce the constant only if it's a constant. Introduce 12, which is a constant, because you can divide it by 12. Like 12 divided by 12 is like 1. It's like we didn't affect our value of this function. So now I can integrate. I have now 1 over 12. Now this is this form. This is the derivative of the denominator. So we have f prime over f of x. The integral of f prime over f of x is ln of f of x. So this would be ln of f of x. My f of x is denominator. Ln of f of x plus c. You see? Simple. All right. I will need you to try this one on your own. Let's say this would be, it was going to be example number 5, but try as exercise. Integrate sec squared of 2x over 1 plus tan 2x dx. So try to integrate this. It should be easy. The hint, you just use the standard integral. Integral of f prime over f of x dx is ln of f of x plus c. Okay. Write the standard integral for this. All right. Let's go to the final example on the log form. Let's say now we want to integrate. This is number 6. We want to integrate 1 over square root of x 1 plus square root of x dx. Before I do this, where you are, can you think, how can I evaluate this integral? I'll give you a minute just to think. Or you can pause this video and try it. Don't cheat, because I'm going to give you a solution now. So far with the understanding also as manje, can you evaluate this standard integral? Pause this video and try this exercise. But mobile uyahluleka, go back. Okay, I'll take it as if you pause this video. Okay, but if ubona uyahluleka again, it's up to you. It's always good to exercise on your own and think. Maths is all about thinking. Here, I want to integrate 1 over square root of x multiplied by 1 plus square root of x. Let me tell you, some student would say I have 1 and then they multiply the square root of x here inside. We multiply a line. Kuzokusiza ngani to evaluate this integral? So when you do things, you should always understanding why you do this. So as long as I have this fraction, I'm always check this second standard integral. So look, it's parallel because I don't have right. So remember, I said this standard integral. If you integrate f prime over f of x over f of x dx. If I like, I can write this standard integral as f prime multiplied by 1 over f of x dx. I can write this standard integral like this. So this will be the standard of this form is going to be ln of f of x plus c. Okay. So let's go back here. The integral, you can write this as 1 over square root of x times 1 over 1 plus square root of x dx. Always zama ukwenza into obonayo ukuthi izokusiza. Sometimes I can give you all the skills, but in maths ekugcineni is all about for you ukuthi ucabange. So you need to think how you can solve this problem. Okay. So if I have here, I may treat this as f of x. I might have the derivative of this outside here. So let's f of x equal to 1 plus square root of x. And the derivative of f of x, I want to check if I have a derivative f prime. I want to integrate something in the form f prime times 1 over f of x. I just took this function as f of x here, like this form. So you see this form. It's the same standard integral as this one. It's just that sometimes I told you we can find some function wrote in this form, like this example. So my follow in this form, this f of prime is right in this form, so your f of x can be like this. So it's in the denominator, and it's 1 over f of x. So you check f of x if it have a derivative here in the numerator, but in numerator very clearly. So I just took my f of x. I said my f of x is 1 plus square root of x. So I want to check if I have f prime here. I want to check if I have f prime here. So this f prime here is the derivative of 1 is 0, derivative of square root of x is going to be 1 over 2 square root of x. You can check the derivative of x to the power of half. You cannot take this half down and then say half minus 1 is going to be minus half. So this minus half will go to the denominator to the power of half, which is square root of x in the denominator. Okay, so this is the derivative of f of x. So the derivative of f of x, I should have a derivative of f of x in order to apply this standard integral. I'm checking here now. The derivative of f of x is 1 over 2 square root of x. But here I have 1 over square root of x. You see, I'm short with this constant 2 here. It's a constant. So what is the rule of the constant? I can always introduce the constant 2. But if I introduce 2, remember to multiply by 2 here. Like 2 divided by 2, it's 1. Like 2 over 1. Okay, 2. So now, as you can see, the derivative of f of x is 1 over 2 square root of x. This is f of x. The derivative of f of x is 1 over 2 square root of f of x. As you see now, I have f prime. F prime is 1 over 2 square root of x. So now I have this form. F prime times 1 over f of x dx. I have integral of f prime times 1 over f of x, which is this form. So the integral here will be, so I can write 2 here. The integral of this form is always going to be also ln of f of x. Ln of f of x. Ln of f of x, my f of x here is 1 plus square root of x. And then you say plus c. Okay. All right. Let me stop here for now. Tomorrow, we're going to focus on this standard integral number 3 and 4, and then start trig form. Trig form, I'll be mixing trig form. As long as you have this one of the from 5 to 14 standard integral, you can apply this. These are all trig standard form, from standard integral number 5 to standard integral number 14. So tomorrow, Friday, I will share with you a lecture on standard integral number 3 and 4, and then start a little bit on trig form. Trig form, I'll be mixing. As long you see one of the standard integral, you'll able to integrate this. Okay. Now I will also share the problems on integration. Yeah. Nalawa sazowazama cover on trig form. So ungabuka mhlawumbe ama problems if you like. Okay, thank you so much.